Okay, good afternoon, good morning, good evening, wherever you're watching this. So these new notes are correct. We do skip to 6.1, so this is the correct notes that are going to be due on Tuesday, um, February 9th. All right, so composite functions. Given two functions, f and g, the composite function denoted by, and we pronounce that f of g of x, okay, or f composed with g. Sometimes people call it fog because it looks like a little O there, but really this notation just means this. And this is the one that should make the most sense to you because all we're doing is that we're inputting one function into another function. We've kind of seen that already. It's the same thing as, if I say if f of x equals 2x plus 1, then what is f of x plus 2? Well, you would substitute x plus 2 in for the function f, right? You don't multiply it. You would actually take this x plus 2 and you'd replace x with x plus 2, and you would get f of x plus 2 is 2 times x plus 2 plus 1, right? Which would be 2x plus 5. So this idea is not going to be new to you guys, but now we just have like a new way of describing it. So we're going to do a few things with this. We're going to evaluate it. We're going to substitute it. We're going to find the domain and range of this. So, all sorts of fun things with these composite functions. So suppose that f of x is 2x squared minus 3 and g of x is 4x, then find the following. So f of g of 1. Let's first make sure we're comfortable with rewriting it. F of g of 1. So, the idea behind this is we find, first what's going on with the input, and then we substitute it back into the original. So, if we break this down in steps, we're going to get first, what is g of 1, right? So all that is 4 times 1, which is 4. And then now we're going to take this 4 and substitute it into the f function, right? Because all we did was we replaced g of 1 with the number 4 because that's what we found. That's when we evaluated it. So now the second thing we do is once we find g of 1, we're going to find f of 4, which is 2 times 4 squared minus 3. So f of 4 is equal to 29. Or in other words, f of g of 1 is equal to 29. Okay, so try another one. Now this time it's g of f of 1. So again, it's good practice just to go ahead and rewrite it like this, g of f of 1. And the first thing we do is, well, let's find what is f of 1. Well, that's going to be 2 times 1 squared minus 3, which is, well, 2 times 1 minus 3, it's negative 1. And then, the big truth is f of 1 is the same thing as negative 1. They mean the same thing. We just found f of 1. So now we have to replace f of 1 with the number negative 1. So now we find g of negative 1, which is 4 times negative 1, which is negative 4. So to write it out the long way, and you don't need to do this, but I just want to emphasize this point, that g of f of 1 is equal to negative 4. All right, so I would try C and D on your own, see if you guys can get that. So pause the video, but I'm going to go ahead and show this for time's sake. So again, we find the inner part first, f of negative 2. Well, what is f of negative 2? Well, that's 2 times negative 2 squared minus 3, which gives us 5. And then once you find f of negative 2, understand that f of negative 2 is 5. That is the number 5. We just found it. So now we find f of 5. Okay, so you're substituting it back into itself, but now we have this newfound knowledge that f of negative 2 is 5, so we replace f of negative 2 with 5, and we do 2 times 5 squared minus 3, so that gives us 47, or in general, f of negative 2 is equal to 47. Okay, so last thing here. First, g of negative 1. So understand this. F of g of negative 1 is f of g of negative 1. That's what that means. So again, it looks fancy, but it's really not. All you're doing is, this is just a substitution problem. So g of negative 1 is 4 times negative 1, which is negative 4. And now we find f of negative 4. So that's 2 times negative 4 squared minus 3. F of negative 4 is 29. Or in other words, f of g of negative 1 is equal to 29. All right, so now, consider your answers of part A and B. Are composite functions commutative? So the commutative property, well, there's two different kinds. There's a commutative property of addition, which is a plus b, that equals b plus a, and the commutative property of multiplication, which is ab equals ba. So what they want to know is, looking at a and b, if I go in reverse, do I get the same answer? Well, no, we didn't, right? We got 29 for a and we got negative 4 for b. However, when they do match up and you get the same thing, you end up getting something special, and we're going to call that inverses, but we'll save that for another day. All right, so again, I think I talked about this when we did things live in class. I really like these kind of problems because they just remind me of like encryption and spying and old school, that famous typewriter that we have that we stole to win World War II, the Enigma machine or something like that. Anyways, we were trying to like decipher a code here. So we don't know what these functions are, f and g, but all we know is their values. We know that when x is negative 3, this is what f and g are. When x is negative 2, this is what f and g are, so on and so forth. So as long as you understand that what f of g of 1 really means is f of g of 1, all we're going to do is use this table to evaluate piece by piece. So first, what is g of 1? Well, here's when x is 1, and here's g of 1. So that means g of 1 is 0. And now we find f of 0. Well, here's 0 and here's f, so that's 2, which we put all together. F of g of 1 is equal to 2. Okay, try it again. First, we always find that inside first. So f of 2, okay, well, f of 2, here's the number 2, here's f of 2. F of 2 is equal to negative 2. And then g of negative 2, well, here's negative 2, that's negative 3. So put it all together, g of f of 2 is equal to negative 3. Okay, one more time. Remember, to truly understand this, you have to understand what this definition is. F of 2 is f of 2. So we're going to first find f of 2. Okay, and then f of 2, well, here's 2, here's f of 2, that's negative 2. Remember, what we just found is what f of 2 is. F of 2 is equal to negative 2, so now to finish it, I find f of negative 2, and here's negative 2, here's f, this gives us 6. So f of 2 is equal to 6. Okay, last thing here, again, pause it and try it on your own, but I'm going to keep going. G of negative 1, well, here's negative 1, here's g, that's negative 2. Again, what we just found, this replaces that g of negative 1. So now I got to substitute this negative 2 in for f, so this becomes f of negative 2. Well, here's negative 2, here's f, and that's 6. So again, f of g of negative 1 is equal to 6. Now this works the same way on graphing. So we have 3 distinct graphs here. We have f of x, we have g of x, and we have h of x. Okay, and again, these along the x-axis, these are the x values that we're going to be looking to evaluate. So again, f of g of 1 really means f of g of 1. So first, we find g of 1. So I look at my table. Here's where x is 1. And where's my g function? Well, that's right here. So g of 1 is negative 1, 2, negative 2, right? So g of 1 is equal to negative 2. Okay, now I'm going to find f of negative 2. So here's negative 2, my x value, 1, 2, and here's my function f. So when x is negative 2, okay, my f function is all the way up here. I'm going to have to throw it out there. I think it's, let's say 15. Okay, it's way above the x-axis, okay? Don't worry, we'll make sure it's crystal clear when you guys have a test or quiz. All right, so h of f of negative 3. Remember, that really means h of f of negative 3. So we're going to find f of negative 3 first. So going to my axis, here's where x is 1, 2. Here's where x is negative 3. And look, right there crosses f right at 0. So f of negative 3 is equal to 0. Now, remember, 0 is f of negative 3. So now I need to find h of 0. Well, here's where x is equal to 0, and here's my h function. And I would say we'd be pretty safe bet to say that it happens at 13, okay? I apologize for going off the graph, but it's real tricky to come up with these problems. G of h of 3. So first we got to find h of 3. Well, h of 3, if I go to 3, 1, 2, 3, this is my h function. So h of 3 is 1, 2, 3, 4. That's negative 4. And then we're going to find g of negative 4. So here's negative 4, 1, 2, 3, 4. And here's my g function right here. At g of negative 4 is 2. So again, to put it all together, g of h of 3 is equal to 2. Okay, again, pause it, try it on your own. Otherwise, we're going to keep going here. H of 1. H of h of 1. So first, h of 1. Well, h of 1, well, here's where x is at 1, and here's h. Okay, I think we're going to go, I think it's at 6. I'd say that's more accurate. So h of 1 is 6. Okay, and now I find, because that's what these mean, now I'm going to find h of 6. So 6 is here, and h is this purple one, so 1, 2, 3, 4. H of 6 is negative 4. So h of 1 is equal to negative 4. All right, now to some fun stuff here. Finding domain of composite functions. Suppose h of x is 1 over x plus 2 and j of x is 4 over x minus 1. Find the composition and domain of each function. Okay, so we're finding h of j of x. No numbers now. And maybe this is a refresher. Maybe this is what you guys want. You don't want to deal with numbers, but this is going to bring some other strong algebra skills that you need right here. So first, let's talk about the domain. Okay, so I know normally you think like, well, you have to find a domain all the way at the end, but we have to first honor what is the domain of the input to make sure that we don't run into any issues. So the first thing we're going to do is find domain of that inner function. So in this case, j of x. So I'm going to find the domain of j of x. So that's 4 over x minus 1. And again, we have a rational function, so we know that x cannot equal 1. Because we plug that in, we're going to have issues with our domain. So now we're going to save this. Okay? We're going to save that to the end. Now let's do the work and let's actually find what is h of j of x. So I'm going to take g of x, and I'm going to substitute it in for x here. So this becomes 1 over parentheses 4 over x minus 1 plus 2. So we have one of those complex fractions that we saw earlier in the year, and we're going to go ahead and simplify it the best way that we know how. So let's take a look at this without parentheses. So it's 1 over 4 over x minus 1 plus 2. So I think we came to a pretty good understanding that we have to multiply everything by the common denominator. So if I just kind of look at these numbers a little bit differently, and I say, well, 2 is really 2 over 1, 1 is really 1 over 1, right? So now I'm looking at three denominators. I have a 1, I have an x minus 1, and I have a 1. So my common denominator is x minus 1. Okay, so again, I'm just looking at denominators there, right? X minus 1 is clearly in the denominator, but there's also a 1, and you could rewrite 1 as 1 over 1. So now I'm going to multiply every single term by the common denominator of x minus 1. So this is going to be 1 times x minus 1, 4 over x minus 1 times x minus 1, and 2 times x minus 1. So this is going to give me x minus 1 in my numerator. This cancels, so I'm left with 4, and I distribute here, and I'm left with 4 plus 2x minus 2. And I clean it up just a tad, not too much to do here, just combine the 4 and the negative 2, and now my new function is x minus 1 over 2x plus 2. So this is the composition of h of j of x. All right, so I just did one part of it. Now, I have to go back. I still didn't find the domain. Remember I said save this for later? Well, my domain is going to be the combination of both of these domains. So it's going to be the combination of the domain of j of x and the combination of my new composite function, h of j of x. So now I get to find what is the domain here? Well, 2x plus 2 can't equal 0. 2x can't equal negative 2. X can't equal negative 1. So the short answer is my domain is x can't equal negative 1 and 1. But again, if you have to do this in Math Excel, then you're going to write it as interval notation, negative infinity to negative 1, union, negative 1 to 1, union, 1 to infinity. All right, so that's my domain, and I used this one, which I wrote save on, and then my new one, which gave me negative 1. Okay, so whenever we're finding a domain of these, you have to find a domain of that input function first, and then you're going to combine it at the end. Let's try B. I have to write really small because there's a lot of room there. I need a lot of room. All right, so first, h of x. Let's first find a domain of h of x. So h of x is 1 over x plus 2. So that means my domain is x cannot equal negative 2. Save it. Okay, we'll come back to that later. Just save it for right now. Now, I'm going to do the groundwork and actually find what is h of x. So, you ever see Inception, a dream within a dream? Well, that's what I'm doing right here. I'm putting a function into itself. So, h of x is 1 over parentheses 1 over x plus 2 plus 2. All I did is I replaced the x in the h of x function with h of x, which is 1 over x plus 2. Okay, so now I have, without parentheses, I have 1 over x plus 2 plus 2. So in order to really get a feel for this, let's go ahead and make sure we can simplify this, and we have to find the common denominator. Well, if I look at this again from a different set of eyes here, I could clearly see that there's a denominator of x plus 2. 2 is the same thing as 2 over 1, and 1 is the same thing as 1 over 1. So if I look at my denominators, I have a denominator of x plus 2, a denominator of 1, and a denominator of 1. So my common denominator is x plus 2. And now I'm going to multiply everything by x plus 2. So this becomes 1 over x plus 2 times, and again, everything is being multiplied by x plus 2. So this is by x plus 2, this is by x plus 2, this is by x plus 2. So my numerator becomes x plus 2 over, these cancel, 1 plus 2x plus 4, and my final simplified answer is x plus 2 over 2x plus 5. Check, right? That's the composition, right? I just found the composition of h of x. I found part of the domain from the original, but now I need to find my new domain from my new one. So again, I have a rational function, and so what makes this rational function undefined? Well, I have to set 2x plus 5 to not equal to 0. 2x can't equal negative 5. X can't equal negative 5 halves. So my domain, final domain, is a combination of this one and this one. So my domain here is x can't equal negative 2 and negative 5 halves. In Math Excel form, it's going to look like this. Negative infinity, 2, negative 5 halves, union, negative 5 halves to negative 2, union, negative 2 to infinity. Infinity. Squeeze it in there. All right. Woo! They're not all going to be that tough, so don't worry. All right, so look, this next one really is not that bad. We're going to do the exact same thing. So f of g of x. So remember, it's the same thing as saying f of g of x. But before I get started, I got to first find the domains of these input functions. So the first thing I got to do before I do any kind of work here is find a domain of g of x. So g of x is the square root of x minus 1. I know that under a radical, I can't have a negative number, so x minus 1 has to be greater than or equal to 0. X has to be greater than or equal to 1. Save it. Okay, save that. We're going to use that at the end. All right, now let's actually find what is f of g of x. So I'm going to take g of x, which is x minus 1, and I'm going to substitute in for x in the x squared category. So this becomes parentheses, the square root of x minus 1 squared plus 1. And cleaning up a little bit, well, you square a square root and you're left with x minus 1 plus 1, which is just equal to x. So f of g of x is equal to x. Okay, check. All right, good. I did part of that. See, that was painless, right? Now the domain. So the final domain. The final domain. Well, if I look at this, this is my new function, x, right? I just did all this work and I got x. So x is a linear function, which means my domain for this is typically all reals. So it's usually all reals. However, for the previous work I did up here, I know that x has to be greater than or equal to 1, and it has to be the combination of both of these. And so by the combination of both of these, my answer is x is greater than or equal to 1. So that's my domain. Or using Math Excel, it's from bracket 1 to infinity, parentheses. Okay, so typically because of it's just x, we'd say, oh, it's all reals. But for the previous work I did, we had to honor this, which is saying x has to be greater than or equal to 1. All right. Let's try this again. G of f of x. So G of f of x. All right, so first, domain of f of x. Well, f of x is x squared plus 1. And I know, if we weren't recording this and I asked you guys to do it on your own, some of you guys would say, well, you're going to set x squared plus 1 to not equal to 0. Or you're going to say, say it's greater than or equal to 0. But just step back a second. X squared plus 1 is a quadratic. That means that my domain is all reals. Okay, it's a quadratic equation. I could put in any x value and it works. So my domain is all reals. Okay, save it. Because we've got to see what the final outcome is. Now, I'm going to find g of f of x. So I'm going to take f of x this time and I'm going to substitute it in to the square root of x minus 1. So this becomes the square root of parentheses x squared plus 1 minus 1. So I drop the parentheses and I get the square root of x squared plus 1 minus 1, which is just the square root of x squared, which is just the square root of, which is just x, right? No square root, because that's the inverse operation. So now I find a domain, the final domain, of both my input, which is all reals, and my new result, which is x, which is also all reals. So they're both all reals, which means my final domain is from negative infinity to infinity, are all real numbers. All right, you may need to hit rewind on that a little bit. Don't worry, we're going to practice the class. That's why I'm doing a recording versus doing the notes in class. All right, so look it over, hit rewind a little bit. But it basically comes down to three things. First, you find a domain of the input, and then you use substitution and simplify. That's what f of g of x is, or g of f of x is. And then you find a domain of the final thing, and you combine both the domains, the first domain and the last domain. All right, so now moving on to something a little simpler. Okay, show that k of m of x is equal to m of k of x, which is equal to x. So anytime they have these show me that, typically you already know the answer. It's going to be x. So now what you got to do is show the work to prove that answer. So they want us to show that the final answer is x, and this is going to have a special name. This is going to be called an inverse. You could save this for later. You could timestamp it and say, okay, what Mr. Vassar said is these are going to be inverses. Yep, you're right. We don't know that word yet, but you will. So let's first take a look at k of m of x, k of m of x. All right, so I'm going to take k of x, or m of x, and substitute it into k of x. That's what that means. So this is going to be k of m of x, 2 parentheses 1/2 times x plus 6 minus 6. So this is, 2 times 1/2 is just 1, right? And I'm left with x plus 6 minus 6, which is x plus 6 minus 6. Well, plus 6 and minus 6, they eliminate each other, and I'm left with just x. Okay, well, let's try it again. This time, I'm going to find m of k of x, which is m of k of x. So all I'm asking you to do now is take your k of x and substitute it into x here. So m of k of x is equal to 1/2 parentheses again, 2x minus 6, close parentheses, plus 6, close parentheses again. So this gives me 1/2. If I drop those parentheses, I have 2x minus 6 plus 6. Well, these are opposites. They're going to eliminate each other. And now I have 1/2 times 2x, which is just x. So I showed it. I knew what the answer was, right? But I had to show it. All right, I love questions like example 2. You're going to see this on a test for sure. Okay, so find functions f and g such that f of g of x is equal to h. So h of x is the final result. But h of x is composed of two other functions, f of g of x. And what we need you to do is use your trained eye to see, well, what could that inner function be that I could substitute in there to create a brand new function that we call h. And sometimes it's obvious, and to tell you what, there's like an infinite number of answers you can give me. You can be as creative or as boring as you want. For example, looking at a, I clearly see that there's an x squared plus 1 inside of a bigger parentheses raised to the 50th power. So in this case, what I see, f of g of x, is you could say that g of x is x squared plus 1, and f of x is x to the 50th power. Okay, that's one of an infinite number of answers. Another answer could be, well, you could say, this is like a little boring, you could say g of x is equal to x, and f of x is equal to x squared plus 1 to the 50th power. I mean, that would like work every time, but that's just really boring. You don't want to do that. All right, so that's, those are a couple possible answers. Try B on your own, but seriously try it. See if you can be creative, figure it out. But I'm going to go ahead and get started. So what I notice here is, so press pause. Okay, what I notice here is there's an x plus 1 in the denominator. So for me, my boring default answer is, well, g of x could be x plus 1, and f of x could be 1 over x. All right, so that's and if you do f of g of x, and you could check this, basically if you take your x plus 1 and you substitute it in for x, you're going to get 1 over x plus 1, which is your h function. Okay, just in time. The bell rang. I got 2 minutes left. The spread of oil leaking from a tanker is in the shape of a circle. If the radius r and the feet of the spread after t hours is r of t equals 200 root t, find the area A of the oil slick as a function of time t. So that means that when I find the area, and I know you guys all know the area of a circle, pi r squared, instead of being in an r, they want this r to be as a function of t. So basically have a t in it. So first of all, area of a circle is a function of radius r. Well, that's our normal formula. Area equals pi r squared. And then radius is a function of time t. Well, they gave us that right here. They said radius is equal to 200 root t. So 200 root t. That's what that means. Radius is a function of time. We're expressing radius in terms of t. Now it says area of the circle as a function of time t. So I'm basically replacing the r squared with my new radius formula. So area is equal to pi times 200 root t squared. And you just clean it up a tiny bit, but it really does not that much work to be shown here. Area is equal to pi times 40,000 t, or it's probably better visually to write it as area is equal to 40,000 t pi. All right, so just above my time limit for you guys, but we're going to get plenty of practice in class. Okay, we'll see you.